notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, number theory and computation. All 33 of those videos have been published on YouTube in their entirety. Section 2, consumer arithmetic. All 12 of those videos have been published on YouTube in their entirety. And I am now working on sets. This is the third out of 6 videos from this section. November 2024. Then by December 2024, end of December 2024, measurements. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. And then by April, geometry and trigonometry. And finally, by May, mid-May 2025, vectors and matrices, and that will take care of all objectives in this syllabus. Just a reminder again that section 1, I have divided into 33 videos. And as I just mentioned, they are all available on YouTube in their entirety. Bear in mind that this section, that is section 1, forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So please make sure you look at all 33 videos and that you know them well if you intend to continue with the rest of the syllabus. Reminder again that you need to know the times tables 2 to 12 if you don't already know them, since calculators are not allowed in paper 1. Section 2, just mentioning that all 12 of these videos have been published on YouTube in their entirety. So that would give a total of 45 videos from sections 1 and 2 have all been published on YouTube in their entirety. Section 3, sets. That is what we are working on now. These 3 objectives here in 2 videos have been published on YouTube. So right now we are on this objective here, objective 4, which is video 3 in this section. And we still have to go up to objective 8. As you can see, this section does not have many objectives. So video 1 already published, video 2 already published. We are now here on video 3, objective 4 in section 3. Total of 6 videos from this section. Only the first 3 will be made available in their entirety on YouTube. The other 3 will be partially available on YouTube, and you will be notified of them if you are subscribed to the channel. And if you want to see those 3 in their entirety, you will be redirected to another site where a reasonable subscription fee is required. So as I said, those were already completed and published. We are now here. Determine elements in intersections, unions, and complements of sets. And we have some explanatory notes here, but since this is too small for you to see, it is written larger here. Intersection and union of not more than 3 sets. And you have to apply this formula here to get the cardinality of the union of 2 subsets. So let's deal with complements of sets first, because that is the easiest to understand. Now, we have met this term before as part of Objective 3.1. We will now briefly review this part of that objective. So, review, where it said, explain concepts relating to sets. And among these concepts, there was one here that said complement of sets. So, if the universal set U has elements 1, 2, and 3, then the odd numbers can be represented as the subset O, 1 and 3. So 1 and 3 is a subset of U, or O is a subset of U. Now, what element or elements is missing from O that is or are included in U? Obviously, that is 2. So we can state that E is 2. Note carefully that subset E has elements that is or are not part of subset O, but included in U. E is therefore said to be the complement of O, of course, within the universal set. So the complement of subset O, written as O prime, is the subset of all other elements in the universal set that are not elements of O. So O prime is equal to E in this case. To summarize, just to make sure you understand this, when U is equal to 2, 3, 4, 8, 9, that's the universal set, and P is 2, 8, and 9, then P complement or P prime will be whatever else is in the universal set but not in P, and that would be 3 and 4. So let's say there's a family where you have 3 children. The universal set would be Peter, Carlos, and Julie. Now, if S represents the sons, Peter and Carlos, then S prime would represent the daughter, which would be Julie. So if the subset Julie is represented by D, daughter, then S prime is the subset D. Still on review, some of these concepts may be made clearer when shown in a diagram called a Venn diagram, and we will look at another Venn diagram in this video, even though that's for 2 videos down. So if you have a rectangle here, which has the universal set U with whole numbers 1 to 20, we can put in all those elements there, 20. Let us say, though, that we want to separate a subset E, which is made up of even numbers in this universal set. So if we draw an oval like that, and we label it E, even numbers, we cannot leave it like that, because inside that yellow oval, you have numbers that are not even, and outside you have numbers that are even. So what we will do, we will need to move the elements that are not in the right place and put them in the right place. So let's remove 5 from in there, and then 3, and then 13, and of course 7. Okay, so what remains here are even numbers between 1 to 20, but we also have some even numbers on the outside, so we have to take those and put them in here. So 8 goes in there, 14 in there, 10 in there, 20 in there, and 18. And I think that is it. Now you have all the even numbers in here. You have all the numbers out there that belong to the universal set. Now, of course, these here are E complement or E prime. They are the odd numbers in the universal set. So I hope that makes it a little clearer what we mean by complement of a set. That was review. We will still consider that a little more in this video. So if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Now, back to this objective. Determine elements in intersections, unions, and complements. And we have to learn how to use this formula. Let's deal with complements of set first, as I said. To reinforce this concept that we just looked at, we will just review from the last slide, but this time not in terms of Venn diagram. So if the universal set is made up of the whole numbers 1 to 20, and E is a subset, which is even numbers, E prime would be odd numbers. You can express that another way. The universal set are these numbers. We actually went ahead and listed them out. The subset E are the even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So what elements are missing from E that are in U? And of course, those would be the prime numbers. So E prime, now that E prime there has nothing to do with the prime numbers, are the prime numbers here 1, 3, 5, and so on. So the complement of a set is the set that includes all elements of the universal set that are not included in the given set. Now, I think that will suffice for complement of sets. We will now consider union of sets. Union of sets. The union of two or more sets is the set of all elements contained in all the sets. The symbol for union is an uppercase U. And that is taken from your syllabus, page 6 to 8. So let us say you have a set P, and its elements are A, B, C, and D. You have another set R, and its elements are E, F, and G. Then the set P union R is made up of all elements in P and R. So it will be A, B, C, D, and then E, F, and G as well. That's union. Union is represented by this uppercase U. You could think of them as add. Note that this has no reference to this U, which represents the universal set. Now, the union of two or more sets is the set that includes all the elements of these sets. If an element is present in more than one set, it is listed only once in their union. So we are still on union of sets. If the elements of the set V are A, B, C, and D, and the elements of the set X are E, F, G, and C, and the elements of Y are E, H, K, D, and R, then if we want this set that represents V union X union Y, so we will write A, B, C, D, E, F, G, that's these three here. We will not write back that C because we already wrote it there. Now, when we come to Y, E was already written in, so we will not write it again. H was not, so we will take H here. K, take that here. D was already written in here. Here. So we will not write back D. And of course, we'll write R here. So the union is represented by the symbol U. As I said, note that it has no reference to this other U here, which is the universal set. So the union of two or more sets is the set that includes all the elements of these sets. And particularly, you need to note that if an element is represented in more than one set, it is only listed once when you state their union. Let us consider grade 9 students at XYZ school who play on the school's cricket team, volleyball team, and football teams. So if C is the set of students that play on the cricket team, Andy, Isaac, Eric, Owen, Kyle, Lisa, Amy, and Tina, and V is the set of students who play on the volleyball team, Emily, Sarah, Melissa, Tracy, Andy, Pedro, and Kyle. And then you have F is the set of students who play on the football team, Tracy, Ken, Melissa, Mario, Andy, Sam, and Colin. So we have these three subsets of students at this school. Now remember, the union of two or more sets is the set that includes all the elements of these sets listed once. So C union V union F would be Andy, Isaac, Eric, Owen, Kyle, Lisa, Amy, and Tina. That would be all of these. Now, Emily is not listed here yet, so we would list Emily. Sarah is not listed up there, so we'd list Sarah. We will also include Melissa here. Tracy is not listed yet, so we will list Tracy. Andy is already listed up here, so we will not list him. Pedro, we will list Pedro here. Kyle is already listed here, so we will not list him again. Tracy is, let's see, Tracy is already listed up there, so we will not list her again. Ken is not listed anywhere, so we will now list Ken here. Melissa is already listed up there. Mario is not listed anywhere yet, so we will now list him. Andy is, let's see, Andy is listed here. Andy is listed here already. Well, Andy is already listed once, so we wouldn't list him again. Sam is not listed, so we will list Sam. And Colin. So now when we look at the set of C, union V, union F, this is what we have. Andy, Isaac, Eric, Owen, Kyle, Lisa, Amy, Tina, Emily, Sarah, Melissa, Tracy, Pedro, Ken, Mario, Sam, and Colin. Now, you do not need to show this step here. So that should suffice for union of sets. We now turn our attention to intersection of sets. Let us just take two of those subsets we just looked at, cricket and volleyball. So these are the cricketers, and these are the students who play volleyball. What elements are common to both sets? Well, you could see Andy is there and here. You could see Kyle here and here, but that is it. So now this symbol here means intersection. It means what is common to both. So C intersection V will be the subset Andy and Kyle. Now the intersection of two or more sets is the set that includes only the elements common to all these sets. The symbol for intersection is this inverted U. So we are still on intersection of sets. Let's consider again those students who play these sports at XYZ school from grade 9. Those who play cricket, those who play volleyball, those who play football. Now, what elements are common to all three sets? Just now, we only looked at the cricketers and those who play volleyball. Now we are looking at all three subsets. So, what elements are common to all three sets? And you look at this and you find Andy is there, Andy is here, and Andy is also here. Andy is the only person who plays all three of these sports. So C intersection V intersection F is the subset Andy. So the intersection of two or more sets is the set that includes only the elements that are common to all the sets. The symbol for intersection is an inverted U. Now consider these three sets shown below. P, made up of these numbers, 2, 4, 6, 8, 10, and so on. They are even numbers from 1 to 20 inclusive. Q, these look like multiples of 3. And R, you have a combination of numbers here, even numbers, prime numbers. So what elements or elements are common to all three of these? And so you could see 6 here, 6 here, and 6 here. You could see 12 there, 12 there, and 12 here. And you could see 18 here, 18 here, and 18 here. So that P intersection Q intersection R is made up of the subset with elements 6, 12, and 18. So the intersection of two or more sets is the set that includes only the elements common to all of those sets. The symbol for intersection is an inverted U. Still on intersection of sets, let's consider these three sets here, P, Q, and R. Now, this may not be the same R that you saw just now in the last slide. Now, what elements are common to all three sets? All three. Well, if you look carefully, there's a 2 up there, there's 2 nowhere else, 4 up there, 4 nowhere else, 6 up here, 6 up here, and 6 down here, but 6 nowhere else, 8 here, 8 nowhere else, 10 here, 10 nowhere else, 12 here, 12 here, 12 nowhere else, 14 here, 14 nowhere else, 16 here, 16 nowhere else, 18 here, 18 here, 18 is not down here, 20 here, 20 is missing there, and 20. So what you see is that P intersection Q intersection R is the null set. There is no element common to all three sets. So it's the empty set in this case. Let's take all of those together. Consider the two sets shown below. The set P has these elements. The set Q has these elements. So what is P union Q? It will be all the elements in the two sets listed once. So it'd be 2, 3, 4. You only list them once. So this 18, for example, here, you don't list it a second time. As an example, what is the cardinality of P union Q? In other words, how many elements are there in P union Q? If you were to count them, you will get 13. Now, what is P intersection Q? What are the elements common to both P and Q? We have 3, 12, and 18. What is the cardinality of P intersection Q? What is the number of elements in P intersection Q? And we get 3. So what is the cardinality of P by itself? 10. Of Q by itself? 6. If you were to add the cardinality of P and to Q, you will get 16. If you were given only what is in this box here, would you be able to get this 13? So you know the cardinality of P intersection Q is 3. You know the cardinality of P alone is 10, and of Q alone is 6. Now using this 10, 6, and 3, how will you get 30? And that is where this formula up here comes in. Because without that formula, well, we can reason it out, but CXC wants us to learn to use that formula up there. So the number of elements in P plus the number of elements in Q is 16. We said that. But in that 16, there are 3 common elements. That is why you have P intersection Q is 3. Therefore, this P union Q becomes 13 when you subtract that 3 from this 16 that is actually counted twice in that 16. So the cardinality of P union Q is equal to the cardinality of P plus the cardinality of Q minus this. The reason for that is that that is counted twice here. So in the 16, if we add 10 and 6, we will get 16. But we have 3 elements common in P and Q. So we will have to subtract the intersection. 6, 12, and 18 appear twice in P and Q, but it is only listed once in P union Q. Let's consider another example. C is made up of the elements Andy, Isaac, and so on. V, these elements. What is C union V? Well, we could list all those persons there once. What is the number of C union V, or the cardinality of C union V? We could count this here. We could count this here. And we get 30. Now, what is C intersection V? Andy and Kyle only. So the cardinality of C intersection V is 2, the number of elements. In the subset C intersection V is 2. What is the number of elements in C by itself? 8. We can count them, 8. What's the number of elements in V by itself? 7. What's the number of elements in both C and V? Counted this way. And you get 15. That is this 8 and 7, 15. But notice we said that the cardinality of C union V is 13. And by now, I think you know how we can harmonize that apparent discrepancy. So do we have a problem here? Not at all. Number of elements in C plus the number of elements in V individually, when you add them up, you get 15. Yes, we do get 15. But in P union Q, there are 2 elements that are common. So now, if we want to find the number of elements in C union V, we will have to subtract that 2 from this 15, and we get that 13, which is this 13 over here. So we subtract this 2. So the number of elements in C union V, or the cardinality of C union V, is the number of elements in C by itself plus the number of elements in V by itself, and then you subtract the number of elements that is common to both C and V. So we are using this formula here. Now calculating N of A union B without listing its elements. So I will list the elements here for the time being. If the set A is made up of these elements and the set B is made up of those elements, then what is the cardinality of A union B? That is what we want to find. Remember, if we didn't have these elements listed here. What is the cardinality of A? That is N of A. It is 10. Let us say you were given that 10 without given this set. What is the cardinality of B? It is 6. Let us say you are given that without this actual set. Then we know that if we add the cardinality of A and the cardinality of B, we will get 16. Let us say you were also given that the cardinality of A intersection B is 3. Let us say we were not given this. We were just given these 3 pieces of information here. That the cardinality of A intersection B is 3. Cardinality of A is 10. And of B is 6. That's all we were given. How will we get the cardinality of A union B? Well, we will use the formula we have up here, which is this. We substitute the numbers we are given. 10, that's this, plus 6, which is that, minus 3, which is this. So 10 plus 6, and then we minus that 3, and we get 13. So the answer to this here is 13. Now, what is A intersection B? Of course, those are the elements if we were given the actual element. And what is A union B? These are the elements if we were actually given the elements. But let us say you were not given the elements. In this case, we could actually write down the elements and count them. But let us say you were not given the elements. You were just given the cardinality of the subsets. Besides, you need to learn how to use this formula up here. It's CXC requirement. And so you may not be given the actual elements, just the number of elements in. Now, let us take a little preview that is from video 5. As a matter of fact, let's use a slide from video 5. To better understand this, let's consider a Venn diagram. You could actually see what is happening. Let us say you have a universal set with 2 subsets. So the universal set are all the natural numbers from 1 to 20. E are the even numbers. E is a subset of U. And are the multiples of 3. T is a subset of U. Now, if we were to draw a Venn diagram to show this relationship, first of all, we will draw a rectangle like that, and we will label it U, natural numbers 1 to 20. So whatever falls in this box down here will only be natural numbers from 1 to 20 inclusive. So we set up a little circle and we call that even numbers, E. We set up another circle like this and we call it T, multiples of 3. Now, do we have anything common to both T and E? In other words, is there any intersection? Do we have any even numbers that are also multiples of 3 in the universal set? And the answer is yes. There is 6, 12, and 18. So those are multiples of 3 that are also even numbers. So what are the other multiples of 3? 3, 9, and 15. So now you have all the multiples of 3 in that red circle. Let's deal with the even numbers in the universal set. 4, we already have 6 here. 8, 10, we already have 12 here. 14, 16, we already have 18 here. And so 20. So if you look at this carefully, you can now see all the even numbers in that universal set. You can now see all the multiples of 3 in that universal set. And you can also see that these 3 are common. So what numbers are not there? Well, 1, 5, 7, 11, 13, 17, and 19. So the cardinality of the universal set is 20. The cardinality of the subset E, even number, is 10. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all in the blue circle. The cardinality of P, multiples of 3, is 6. You can count them. 1, 2, 3, 4, 5, 6. You also know that the cardinality of E intersection T is 3. That is, these three numbers here. So now, what is the cardinality of E union T? Now, if we count all the numbers in the blue and red circles, we will get 13. But remember, you're only counting 6, 12, and 18 once. Let us say you didn't know that, and you only have this piece of information here. How will you come up with that 13? So we use the formula that we are given up here, which says that the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. So remember, you only have these pieces of data here. So let's substitute A and B with E and T. So you get this formula here. Substitute the numbers. Cardinality of E is 10, that is this 10 up here. The cardinality of T is 6, that is this 6 up here. And the cardinality of E intersection T is 3, which is this 3 up here. Now 10 and 6, 16 minus 3 will give you 13, which is this number here that we wanted to get from this formula up here. So now let's find unions not given actual sets. Now using this formula, example 1, if you know that n of A is 35, n of B is 20, and n of A intersection B is 8, calculate the cardinality of A union B. We take our formula from up here, substitute the numbers, 35, that's this 35, plus 20, which is that, minus 8, which is this, and you get the number of elements in A union B is 47, without actually counting the elements. Example 2, using this formula again, if you know that the cardinality of the set R is 17, and of S is 13, and of R intersection S is 7, find the number of elements in R union S. So we take our formula that we have up there, up here, we substitute n of R, which is 17, which is this, plus n of S, which is 13, which is that, and then we subtract from that n of R intersection S, which is 7, and so the answer to that is 23. So we will look at one final one using this formula. If you know that the cardinality of P union Q is 40, and that of P by itself is 24, and of Q by itself is 25. Calculate the cardinality of P intersection Q. In this case, we will need to change the subject of the formula. The subject of the formula here is n of A union B, or P union Q. So we need to change the subject of the formula. So this is the formula, this is the subject, which we were finding all along the line. But now we know that. We also know this, and we know that. We want to find this. So we will change the subject of the formula, and we get cardinality of P intersection Q is equal to cardinality of P plus cardinality of Q minus the cardinality of P union Q. Let's substitute the numbers we are given. 24 here, which is that, which is this, plus 25 here, that, which is this, minus 40, which is this here. And so we work that out and we find that we have 9 elements common to both P and Q. And I think that that should suffice for this objective. Objective 4, determine elements in intersections, unions, and complements of sets. And we learned how to use this formula as required by the syllabus. And that brings us to the end of this video, video 3, based on Objective 4 in Section 3.